Okay, next is about the electrolysis of an aqueous salt solution. So you need to remember anything yang melibatkan aqueous, yang ada perkataan aqueous ni, okay, ataupun phase AQ, contohnya lah NaCl aqueous ataupun KCl aqueous. Itu adalah aqueous salt solution. Salt NaCl, KCl. Salt ni ialah ionic combination of ion, cation and anion lah yang di-combine together. So dia NaCl, KCl lah macam ni lah. Okay, asalkan dia ada aqueous, perkataan aqueous ataupun fasa aqueous and also solution, you need to remember that dia ada kehadiran water molecules there. Okay, so it's not just, contohnya lah kalau nak tahu ion apa yang berada dekat solution ni, it's not just Na plus dengan Cl minus, dia akan ada H2O sekali. Okay, kalau let's say if this an aqueous salt solution, you kena masuk, kira masuk kehadiran H2O di situ ya, H2O molecules. Okay, and water is an electroactive substance that may be oxidized or reduced. So kita dah belajar tadi the electrolysis of water. Kita tahu H2O ni dia boleh undergoes oxidation and dia boleh undergoes reduction, and dia ada masing-masing mereka punya half-cell reaction equation bila dia undergoes oxidation and reduction. So therefore, kalau you nak tahu product of the electrolysis aqueous salt solution, dia mencabar sikit. Sebabnya bukan saja you kena tengok cation and also anion, tetapi you kena tengok SRP value for the H2O as well. Sebab kita nak tahu siapa yang terpilih dekat anode dan siapa yang terpilih dekat cathode. Sangat penting tu. Sebab kenapa? Because electrolytic cell is all about apakah produk yang terhasil dekat anode dan di cathode. Siapakah yang selected at the anode dan di cathode supaya kita boleh tahu produk yang berada di anode dan di cathode, and lastly kita boleh buat conclusion, observation apakah yang you boleh nampak dekat anode dan di cathode based on the product of the half cell reaction equation yang terpilih dekat anode dan di cathode for electrolytic cell lah. Okay. Okay, contohnya lah, if let's say kita nak buat electrolysis of an aqueous NaCl, so you have to know, kalau let's say dia mention kat sini, okay, aqueous NaCl, that means di dalam electrolyte tersebut, okay, di dalam electrolyte tersebut akan ada ion Na plus, akan ada ion Cl minus, and also ada kehadiran H2O. H2O ni dia masing-masing boleh undergo oxidation or reduction. So you kena choose, nanti ada cara-cara dia macam mana nak choose the one yang akan undergo oxidation ke reduction. Okay. So basically the aqueous solution of NaCl ni dia ada water molecule as what I told you earlier, and dia akan ada Na plus and Cl minus ions. Okay, so kat sini nak tahu dekat cathode, both Na plus ion dengan H2O molecules akan attracted pada cathode, and di anode pula Cl minus ion dengan H2O molecules. Persoalannya kat sini, siapakah yang akan terpilih? So nak tahu siapakah yang akan terpilih, nanti Miss akan terangkan later. Okay. So actually the product of electrolysis of aqueous NaCl solution ni, it depends pada concentration of the electrolyte. Sebab itulah you kena tengok soalan tu, dia bagi tahu is it a concentrated aqueous NaCl ke or diluted aqueous NaCl. Okay. Okay, so there are a few factors that affect the products of electrolysis of an aqueous salt solution. The first one is the SRP value. The second one is the concentrations of the aqueous ions, some either they're very dilute or concentrated. And the third one is the types of electrode used, some either dia guna inert electrode ataupun active electrode. Okay, generally, to predict the product of electrolysis of an aqueous salt solution, first thing first, you tengok dekat electrolyte you tu, aqueous electrolyte tu, what kind of ions ataupun species yang berada di dalam electrolyte tersebut. Okay, next, nak tentukan siapa yang pergi dekat cathode dengan anode. Okay, kalau kat cathode, you have to choose ion ataupun species yang ada higher SRP value supaya senang nak buat reduction. Okay, I know at the cathode, we have discussed earlier, Kalau electrolytic cell kat cathode, metal senang nak deposit kan. Sebabnya kalau dekat cathode dia buat reduction, uh, dia akan gain electron. So the product dia usually kamu akan dapat metal. Tapi reactive metals such as sodium and potassium will never be produced at the cathode. Okay? Kalau copper tak apa. Macam tu. At the anode, tengoklah type of electrode yang digunakan juga and also concentration of the ions. Okay? Sebab benda ni akan mempengaruhi selection of the species yang berada di anode. Okay, kalau let's say type of electrode, kita boleh tengoklah sama ada dia inert ataupun active electrode. Kalau inert electrode, dia akan choose ion yang ada lower SRP value unless electrolyte tu ada high halide ion such as Cl- or Br-. Kalau active electrode contohnya macam copper. Okay, electrode tu dia akan dissolve to form metallic ion. Dia akan buat oxidation. Kalau based on concentration, nanti kita akan learn about this later. Okay. Usually kalau let's say it's a very dilute, kalau if it's a very dilute, dia akan ikut SRP value. Okay. Kalau let's say if it is a concentrated, nanti kita akan choose the one yang lagi concentrated. Nanti kita akan bincang about this later. Okay, to talk more about the SRP value punya factor on the predicting the product of electrolysis of an aqueous salt solution. Kalau let's say you nak compare the SRP value, nak tahu kalau let's say lah, if let's say you have the electrolyte tu, you have the aqueous salt solution, dia akan consist of an ion, cations and also H2O, right? Okay, lepas tu dekat anode akan species tu mestilah akan undergoes oxidation, dekat cathode species tu akan undergoes reduction. Okay, normally dekat anode, negative ions ataupun anions ni dia akan lebih tertarik kepada anode dan dia akan undergoes oxidation. Tapi since that if let's say we have aqueous salt solution, dia akan ada pertambahan H2O. Okay, di mana anions tu dia akan bertanding, tak adalah bertanding, dia akan tak tahu mana satu, adakah anion ataupun H2O akan tertarik untuk buat oxidation di anode. Okay, so basically kalau let's say you ada dua species macam di sinilah kan, ada anions, ada H2O, tak tahu mana satu yang akan pergi kepada anode dan undergoes oxidation. Kalau ikutkan factors SRP value, basically dekat anode ni kita akan choose the one yang ada more negative SRP value untuk untuk buat discharge di anode, untuk pergi kepada anode. For example, kalau let's say you ada dua jenis species dekat anode, contohnya lah you ada iodine, you ada Br, macam ni lah kan, with different SRP values respective to each of the species ni. Since that at the anode we need to choose the one yang ada more negative SRP value. So in this case, kalau kita comparekan antara dua ni, iodide will be oxidized just because of dia ada more negative SRP value. At the cathode, normally positive ion ataupun cations dia akan lebih tertarik untuk buat reduction di cathode. Okay, tapi kalau you ada more than one reducible species, for example in this case if we have you nak tahu, nak choose mana satu, is it Na+ ataupun H2O. H2O kan bila dia undergoes reduction, this is dia punya half cell reaction equation with dia punya respective SRP value kan. Okay, tapi kalau nak ikutkan factor SRP value, kalau kat cathode, normally we will choose the one yang ada more SRP, more positive SRP value. So, for example, kalau dekat cathode ni, you tak tahu you nak choose within cation Na+ ataupun H2O, you look at the SRP value, yang the ones yang ada more positive SRP value, itulah dia yang akan terpilih untuk undergoes reduction at the cathode. So in this case, water molecule will be reduced at the cathode. Okay, kalau let's say you nak tengok position of the positive ion in the electrochemical series pula, kalau dekat anode, memanglah usually an ion akan lebih attracted kepada anode kan, sebab senang nak lose electrons, nak buat oxidation kan. Tetapi if let's say you have CuSO4 aqueous solution, bermaksud kat sini dia ada Cu2 plus ion, SO4, 2 minus ion, and also since that dia aqueous, ada kehadiran water di situ. Tetapi kalau ke anode, dia akan dua spesies lah yang you kena choose untuk buat oxidation di anode, sama ada anion SO4 2 minus ataupun H2O yang akan undergo oxidation. Okay, kalau ikutkan previously, we said that kalau dekat anode, dia akan choose SRP value yang more negative kan. So, kena tengoklah SRP value of SO4 2 minus dengan H2O ni bila dia buat oxidation. Tetapi, kalau nak senang kat sini, dia dah bagi tahu siap-siap, a large resonance stabilized oxoanions such as SO4 2 minus dengan NO3 minus will never be discharged. Dia tak akan terpilih untuk buat oxidation di anode. For example, if you ada CuSO4 aqueous salt solution, memanglah ada kehadiran anion SO4 2 minus and also species H2O molecules kan, untuk dipilih sama ada dia attracted dekat anode ni mana satu. Since that kat sini dia dah bagi tahu SO4 2 minus memang tak akan buat oxidation dekat anode, since that is a large resonance stabilized anions, so dia tak akan terpilih. So kat sini tu dah mudah dah kerja you. Kalau you hafal about this fact, you know that SO4 2 minus tak akan terpilih untuk buat oxidation at the anode. Therefore H2O punya half cell reaction equation yang undergoes oxidation ni akan terpilih untuk buat oxidation di anode. Okay, and also for example, kalau let's say nitrate ion juga, for example, if let's say you ada AgNO3 silver nitrate aqueous solution. Okay, silver nitrate aqueous salt solution, kalau you jadikan dia sebagai electrolyte, di dalam electrolyte tersebut akan ada ion Ag+, ion NO3-, and also ada H2O molecule. Just because of this is aqueous salt solution. Again, you tengok ni, kalau NO3- will never be discharged, okay. Since that kalau at anode ni, kalau if it is an aqueous salt solution, memang an ion dengan H2O akan berada di anode, so you have to choose which one. So since that NO3- will never be discharged, so easily you can just pick H2O yang undergoes oxidation lah as the half cell equation yang akan berada di anode. Okay. How about cathode? Cathode pula, metals yang less reactive akan ada greater tendency to be discharged. Okay, kiranya kalau metals tu dia lagi less reactive, dia lagi senang nak terpilih untuk berada di cathode. Okay, ataupun ions yang ada metalnya yang ada more positive SRP value pun senang nak dipilih untuk berada di cathode. Alright, next, kalau ikutkan factor concentration of the species, okay, if it is a high concentration aqueous salt solution, the higher concentration of the ion tu dia lagi senang nak discharge, okay, except active metals. Active metals apa? Active metals such as Na, sodium ataupun potassium, and oxoanions. Oxoanions tadi kita dah discuss, it is SO4 2 minus ataupun NO3 minus. Okay. For example, kalau let's say you nak tentukan which one yang akan berada di anode dan di cathode for the electrolysis of an aqueous salt solution CuSO4. Okay, first thing first, you kena identify all of the species yang berada di dalam this electrolyte. Okay, since that this is an aqueous salt solution, We tahu dekat CuSO4 ni kita akan ada ion Cu2+, kita akan ada ion SO4 minus, and also since that it is an aqueous solution, therefore akan ada kehadiran H2O kat situ. So sekarang ni at the anode, kita tahu at the anode kita ada H2O, sebab H2O dia boleh undergo oxidation. As we can see from the previous electrolysis of water, H2O dia boleh buat both oxidation and reduction, tapi dia ada different half cell reaction equation respectively lah. Okay, so at the anode, since that H2O boleh undergo oxidation, so dia boleh berada di anode. And also anode dia suka anion. So anion in this case adalah SO4 minus. So at anode akan ada dua species. At cathode pun ada dua species, which is Cu2+, cation Cu2+, and also H2O, since that H2O boleh undergo reduction. Cumanya persoalan kat sini, kan, which one yang will be selected? Okay, which one will be selected? Macam mana you nak tahu? Kita boleh tengoklah faktor-faktor previously yang you dah belajar. Kalau let's say SRP value punya factor, kalau anode dia akan tend to choose the one yang ada lower SRP value. Kalau cathode dia akan choose the one yang ada higher SRP value. Okay, tapi in this case and also anode dia tak akan choose oxo anion such as SO4 minus. We have discussed this previously. So basically at the anode, as you can see, ada dua species kat sini. Since ada SO4 minus, kita boleh discard. Kita boleh discard SO4 minus sebab dia tak akan choose SO4 minus, so dia akan choose H2O yang akan undergo oxidation at the anode. Dekat cathode pula dia akan choose mana satu? Dia akan choose Cu2+, because Cu2+ ada higher SRP value. Okay, so you tengok balik this kind of fakta. Okay, mana satu yang dia tend to choose. Okay. Okay, for example, what is the product of electrolysis of an aqueous salt solution kalau let's say electrolyte kamu tu adalah a very dilute NaCl solution? Okay, so untuk tahu apakah spesies yang berada dekat NaCl solution, you kena bagi tahulah kat sini dalam NaCl solution akan ada cation Na+, anion Cl-, dan juga kehadiran water H2O. Okay, and then the next step is identify spesies mana yang akan will be selected at the anode and cathode. Okay, kat anode dia akan attract an ion and also H2O molecules, since that H2O molecules ni boleh undergo oxidation. So ada dua species yang boleh undergo oxidation here, which is an ion Cl- and also H2O molecules, tetapi kamu kena pilih mana satu. Nak pilih mana satu, you have to look at the SRP value factor in here. Okay, since that this is a very dilute aqueous salt solution, so you have to look at the SRP value. As you can see here, this is the SRP value untuk Cl- bila dia undergoes oxidation, and this is the SRP value for the H2O molecules bila dia undergoes oxidation. Benda ni Miss suruh hafal supaya senang. Okay, so at the end, I told you guys, if it is a very dilute, for the anode, you have to look at the SRP value, which one yang more negative. So which one yang more negative is the SRP value H2O molecules bila dia undergoes oxidation. Therefore, H2O will be selected for oxidation for the very dilute aqueous NaCl solution. Okay, so next, how about at the cathode? Okay, kat cathode akan ada species Na+ and also H2O molecules, tapi this H2O bukan yang this one. This H2O ialah H2O yang boleh undergoes reduction. Since at the cathode akan undergoes reduction. So, okay, you tengok SRP value untuk Na+ dengan H2O bila dia undergoes reduction. This is the SRP value for H2O bila dia undergoes reduction, which is negative 0.83 volt. Okay, to choose the one yang akan selected at the cathode, you have to look at the SRP value juga. Okay, the one yang ada SRP value yang more positive will be selected to be discharged at the cathode. So as you can see here, the SRP value H2O dia bila undergoes reduction adalah sebanyak negative 0.83 volt. Dia lagi more positive. So H2O will be selected for reduction at the cathode. Okay, in subtopic 3.3 ni, it's all about you kena determine which one yang will be selected at the anode and the cathode supaya you boleh tahu produk dia apa. So nanti you boleh write down observationnya apa. So in this case, if let's say you ada electrolytic cell that is a very dilute aqueous salt solution NaCl solution, okay, so the full reactions yang involved adalah, okay, yang dekat anode kita dah choose tadi, the one yang akan undergo oxidation adalah water, since that water molecule dia punya SRP value dia apa tu, lagi more negative compared to Cl minus. Okay, and also di cathode pun kita choose water juga, sebab kenapa? Dia ada more positive value compared to Na+. So nanti apa yang akan berlaku ialah this is the full reactions, okay. Kiranya this is just like the electrolysis of water punya reaction, since that dekat anode dengan cathode kita choose both of them water, since that SRP value dia apa tu, ngam lah untuk ni kan. Okay, so after all this is the, ni cepatkan sajalah sebab I dah bagi tahu kan the overall reaction of water punya electrolysis macam mana. Okay, tapi yang paling penting ialah observation dia. So for a very dilute NaCl solution as the electrolyte, dia punya observation dia at the anode, dia akan follow water punya oxidation at the anode lah, which dia akan liberate the oxygen gas, and also the solution will be acidic. While at the cathode, since that kita choose H2O to be the one yang akan undergo reduction at the cathode, sama juga hydrogen colorless gas akan produce, and also the solution will become basic since that OH minus ions are produced. Okay. Okay, tadi kita dah belajar macam mana cara nak predict the product of electrolysis of a very dilute aqueous salt solution. Di mana the product atau the species yang akan terpilih dekat anode dan di cathode, it all depends pada SRP value masing-masing lah. Kalau dekat anode kita akan choose the one yang more negative SRP value, kalau dekat cathode kita akan choose the one yang more positive SRP value. Tapi what happen if let's say you have this kind of example, what happen if you have a very concentrated aqueous salt solution, in this case NaCl solution. Okay, as usual, kalau kita gunakan NaCl solution sebagai electrolyte, kita tahu di dalam NaCl solution ni akan ada cation Na+, anion Cl-, dan juga since that it is a solution, akan ada kehadiran water kat situ. Tapi persoalannya, since that sekarang ni faktor yang mempengaruhi spesies yang akan pergi kepada anode dan di cathode ialah concentration of the ions itself. How about kalau let's say you ada a very concentrated aqueous salt solution. Okay, so let's look here. At the anode, as usual, kita akan ada dua spesies yang kita nak kena pilih kat sini. Sama ada anion Cl- ataupun H2O molecules, since that H2O molecules boleh undergo oxidation. Okay, kalau let's say dia very dilute, kita tengok SRP value. Okay, mana yang lagi negatif kita akan choose, which is water. But in this case, it's different because this time around, what happen kalau you ada a very concentrated aqueous salt solution? So, the one yang akan terpilih dekat anode adalah the one yang ions yang lagi concentrated. In this case, ions yang lagi concentrated adalah Cl-. So, kita tak tengok SRP value, okay? Kalau let's say you ada concentrated aqueous salt solution, untuk tentukan mana satu di anode, okay? Untuk tentukan mana satu di anode, kita tak tengok SRP value. Kita akan choose ion yang lagi concentrated. In this case, ion yang lagi concentrated adalah Cl-. So Cl- ni yang akan terpilih untuk pergi buat oxidation di anode. Okay. Kalau kat cathode pula, kalau for a concentrated aqueous salt solution macam mana? Kalau untuk concentrated ke very dilute ke, kalau let's say di cathode, tak kisahlah dia concentrated atau very dilute, dia kena tengok SRP value. Okay. So kita tahu dekat cathode akan ada dua spesies yang you have to choose, sama ada cation Na+ or H2O yang boleh undergoes reduction. So you can have to look at the SRP value, since the SRP value for the H2O yang undergoes reduction, dia ada more positive SRP value, so we will choose H2O to undergoes reduction at the cathode. So, the full reactions yang involved in the electrolysis of a concentrated aqueous salt solution NaCl adalah, since kita dah choose dekat anode yang akan undergo oxidation is the most concentrated ions, which is Cl-. So, this is a half cell reaction equation of Cl- bila dia undergoes oxidation, which dia akan lose electron and with respective SRP value. And this is the H2O molecules bila dia berada di cathode and undergoes reduction. Dia akan gain electron, and this is dia punya half cell reaction equation with the respective SRP value. So the overall cell reaction equation, since that dia punya number of electrons for both the anode and cathode dah balance already, we can just cancel it out and kita bawa turun je the balance. And also if you calculated dia punya inert cell, this is what you will get, which we know that the reaction is non-spontaneous. Tapi yang penting adalah observation. Okay, observation yang tinggal bila nak bagi tahu product of electrolysis in the electrolytic cell ni. Observation, as you can see, since that dekat anode kita choose Cl- to undergo oxidation, dia akan menghasilkan produk Cl2 gas. Okay. Cl2 gas ni color dia, kalau you boleh tengok dengan mata kasar, bila dia release the Cl2 gas, dia punya color adalah greenish yellow. So you can write at the observation greenish yellow gas is liberated. Tapi kalau you tak letak Cl2 pun tak apa, kalau you dah tahu you nak letak Cl2 pun boleh, since that kita dah buat dia punya half cell reaction equations, and we know that Cl- bila dia lose electron, dia akan menghasilkan chlorine gas. Okay. And at the cathode, since that kita choose water molecules to be the one yang akan undergo reduction at the cathode, and this is the product that dia hasilkan, which is dia menghasilkan hydrogen gas, and also the solution will become basic since that dia release OH- juga. So this is the observation at the cathode lah for the electrolysis of concentrated NaCl solution. Hydrogen colorless gas is produced, and the solution becomes basic since the OH- ions are produced. Okay. So you can take note, okay, that the electrolysis of aqueous NaCl will produce oxygen at the anode only if the solution is very dilute. Yang ni concentrated. Okay, kalau very dilute kan kita akan choose H2O molecules. So that's why kita akan dapat oxygen gas punya product at the anode. Tapi kalau dia concentrated, that's why kita akan dapat greenish yellow chlorine gas. Okay, under real condition, electrolysis of aqueous NaCl will produce Cl2 at the anode lah kalau under real condition, and also if it is a concentrated ones. Alright. Okay, previously Miss gunakan salt NaCl sebagai contoh untuk kamu predict the product of electrolysis of an aqueous salt solution. Kalau let's say dia very dilute NaCl solution, the electrolysis dia will be just the same as the electrolysis of water. Kalau concentrated NaCl solution is a different case, since that kita akan choose ions yang lagi concentrated. But in this example, what happen if you have an aqueous salt solution yang daripada NaCl tu means gantikan dengan Na2SO4. What if you nak kena predict the product of electrolysis of an aqueous salt solution Na2SO4. So kat sini dia bagi tahu electrolysis of sodium sulfate solution ni sama je macam you buat electrolysis of water, sebab oksigen dengan hydrogen gas will be produced. Sebab kenapa ya? Okay, untuk fahamkan benda ni, you need to know if let's say you gunakan electrolyte aqueous Na2SO4. Okay, di dalam Na2SO4 aqueous solution ni dia ada Na+, SO4 minus dengan H2O molecules. So during an electrolysis, dekat anode mestilah akan ada anion and also H2O molecules. Dekat cathode pun dia akan attract Na+ ion and H2O molecules. Persoalannya, siapa yang akan terpilih? Okay, untuk tahu siapa yang akan terpilih dekat anode dengan cathode, kita tahu dekat anode ada dua spesies yang you boleh oxidize, so you need to choose which one. Okay, previously we have learned that anything yang a large oxo anion such as SO4 minus ataupun NO3 minus is a no-no. Dia tak akan terpilih untuk buat oxidation di anode. Therefore, in this case at the anode, H2O will be selected for oxidation. Okay, lagi satu, kalau tengok SRP value for H2O yang bila dia undergoes oxidation pun, dia punya SRP value dia more negative compared to SO4 minus. Next, which one yang you nak kena pilih yang dekat cathode? Kat cathode sekarang ada dua spesies yang you boleh buat reduction, sama ada Na+ ataupun H2O yang boleh undergo reduction. So this one, if you look at the SRP value, okay, SRP value yang more positive will be selected at the cathode. So we can see the H2O molecules ni bila dia undergo reduction, SRP value dia more positive compared to Na+. Therefore, H2O will be selected for reduction. That's why dia bagi tahu tadi previously, the electrolysis of aqueous Na2SO4 solution is just the same like the electrolysis of water. Sebab since that dekat anode dengan cathode, kita choose dua-dua ni H2O. H2O ni yang terpilih. So since H2O yang terpilih yang berada dekat anode dengan cathode, so it will be just the same as the electrolysis of water, although that you tengah gunakan electrolyte Na2SO4 aqueous solution. Tetapi since that dalam selection yang untuk berada di anode dan cathode ni, H2O yang terpilih, H2O yang undergoes oxidation terpilih dekat anode, H2O yang undergoes reduction terpilih dekat cathode. So basically dia akan ikutlah reactions macam electrolysis of water. So basically observation dia pun will just be the same like the electrolysis of water, which at the anode, walaupun you tengah nak buat electrolysis of an aqueous Na2SO4 solution, tapi since that H2O yang selected, so at the anode, H2O yang undergoes oxidation at the anode adalah dia akan hasilkan oxygen gas. So you will see oxygen colorless gas produced, and also the solution will become acidic since H+ ions are produced. Okay. At the cathode, since H2O yang undergoes reduction yang terpilih, ni adalah produk bila H2O tu undergoes reduction di mana hydrogen gas will be released, and also the solution will become basic since OH minus ions are produced. Okay, so the last factor yang boleh mempengaruhi the product of electrolysis of an aqueous salt solution is the types of the electrodes used, sama ada dia active ataupun inert electrodes. Okay, kalau inert electrode, dia takkan participate in the redox reaction of the cell. Contoh inert electrode adalah graphite dan juga platinum. Kalau contoh active electrode ialah macam copper macam ni. So active electrode dia akan participate in the redox reactions of the cell. Okay, so let's discuss about the product yang akan produce if kita gunakan inert electrode ataupun active electrode. Okay, for example, kalau let's say kita gunakan inert electrode yang direndam di dalam electrolyte copper sulfate solution, okay, apa yang akan berlaku? Kita tahu dekat dalam copper sulfate solution akan ada spesies copper 2 plus, SO4 2 minus and also H2O. And kita tahulah kat anode dia akan nak pilih lah sama ada SO4 2 minus atau H2O. Kat cathode sama ada Cu2 plus dengan H2O. Okay, since that previously I already told you guys kalau inert electrode dia tak akan participate in the redox reaction. Therefore, kat anode, kalau let's say ada SO4 2 minus, kita tahu SO4 2 minus will not be selected. Okay, sebab SO4 2 minus is a very large resonance ion, so dia tak akan terpilih. Therefore, H2O yang will be selected to be oxidized at the anode. So this is it, the H2O molecules bila dia buat oxidation at the anode. And dekat cathode pula, dia akan pilih Cu2 plus lah, because I think in this case Cu2 plus dia punya SRP value is more positive. Okay, so about the observation, since that kita dah tahu siapa yang berada di anode dan di cathode ni, kita tengok sahaja produk of the half cell reaction equations at the anode and cathode. So kita boleh terus tulis lah. Kat sini sepatutnya kena ada letak phase. Okay, kena letak fasa-fasa. Okay, H2O is a liquid phase, oxygen gas, H plus aqueous. Okay, Cu2 plus adalah aqueous and Cu solid. Supaya senang you nak buat observation nanti. Therefore, at the anode we know that colorless bubble gas will be formed, which the colorless bubble gas adalah oxygen. And also the solution will become acidic since that H plus ions is produced. Okay, and at the cathode, since that copper 2 plus dia gain electron sebab dia undergoes reduction, so dia akan menghasilkan copper solid. So therefore copper solid will be deposited at the cathode. Deposit tu maksudnya dia melekat lah kat cathode. Okay. Okay, and the next, active electrode. What happen kalau you gunakan active electrode di dalam electrolyte yang ada active electrode ni lah kan. Okay, for example, if kita gunakan active electrode copper yang direndam di dalam electrolyte copper sulfate solution, previously I already told you guys yang active electrode akan participate. Dia akan participate in the redox reaction itself, walaupun dekat anode initially, since that this is a aqueous salt solution, so dekat anode supposedly lah yang akan attracted adalah SO4 2 minus ataupun H2O. Kat cathode Cu2 plus ataupun H2O. Since that we are using the active electrode here, so active electrode dia akan participate, dia akan masuk campur. Okay, dia akan participate in the redox reaction. So since dia participate in the redox reaction, therefore we can see at the anode dengan cathode here kita gunakan copper for both. At the anode and the cathode kita akan choose copper. Cuma ni dekat anode kita akan choose copper yang undergoes oxidation, di mana dia akan release electron. Okay, and dia akan menghasilkan copper 2 plus ion. Di cathode pula dia akan undergoes reduction, di mana dia akan gain electron dan dia akan menghasilkan copper solid. Okay, so please don't forget to put all the phase here so that you will know. Nanti dekat observation you tengok saja dekat product of the anode dengan cathode. Kalau product of the dekat anode ni you nampak dia hasilkan copper 2 plus aqueous. Okay, bermaksud kat sini kita boleh bagi tahulah there will be copper yang dekat anode ni dia akan mengurus, will be thinning. Okay, sebab kenapa dia release copper 2 plus ion, so, and then at the cathode the copper will be deposited at the cathode. Sebab you boleh tengok produk dia kat sini lah, copper solid. Okay, Okay, so let's try this out. Contoh lah, kalau you ada this kind of soalan, dia bagi kamu set up for the electrolytic cell for the electrolysis of a dilute copper to sulfate solution. Okay, bermaksud kat sini, dia gunakan electrolyte dilute copper to sulfate solution. Okay, dia suruh kamu explain the chemical reactions yang berlaku in the cell and state the product form at X and Y electrodes. Okay. X and Y electrodes both are inert electrodes. So kalau inert electrodes, dia tak akan involve in the redox reaction. Okay, and also you need to know electrode X ni adakah di anode atau cathode. So you have to look at the battery terminal here. So I believe this one is a positive terminal and it is connected to the electrode X. Therefore, electrode X adalah anode. Okay, and then electrode Y adalah cathode, since that it is connected to the negative terminal of the battery. Tapi untuk you tahu produk mana satu yang akan selected at the anode and the cathode, tu you kena buat jalan kerja sikit lah. Okay, since that you know that di dalam solution electrolyte ni, it is a very dilute copper to sulfate solution. Kalau dilute, okay, any dilute aqueous salt solution, okay, dia akan tengok, nak select the one yang berada di anode dan di cathode, tengok SRP value. Okay, kalau dekat anode, dia akan pilih SRP value yang lagi negatif. Kalau kat cathode, dia akan tengok SRP value yang lagi positif. Okay, and then since this is a dilute copper to sulfate solution, therefore di dalam solution ni akan ada species copper 2 plus, SO4 2 minus, and also H2O molecules. Okay. Okay, so for the solution part, since that we have determined electrode X adalah anode, since that it is connected to the positive terminal of the battery, electrode Y adalah cathode, since that it is connected to the negative terminal of the battery. Therefore, at anode, kita akan ada dua species yang kita boleh oxidize here, which is anion SO4 2 minus and H2O. Cathode, kita akan ada another two species yang kita boleh buat reduction, which is Cu2 plus cation and also H2O molecules. Okay, step 2, since that the hint dekat soalan tu dia bagi tahu it is a very dilute aqueous salt solution. So untuk select species yang dekat anode dan di cathode, you boleh refer pada SRP value. Okay, contohnya lah dekat anode, dia akan tengok SRP value yang more negative. Okay, so if you compare the SRP value for SO4 2 minus and also H2O molecules bila they undergoes oxidation, we can see that H2O molecules will be selected since that it has the lower SRP value compared to SO4 2 minus. Okay, untuk choose the one yang berada di cathode, okay, we need to choose the one yang ada more positive SRP value. Okay, so kalau kita compare SRP value copper and also H2O bila dia undergoes reduction, we can see that copper will be selected just because dia ada higher SRP value compared to H2O molecules. Okay. Okay, so since the question asks you to explain the chemical process that is happening, so you bolehlah, once you dah decide siapa yang berada di anode dan di cathode, you bolehlah bagi tahu dia punya overall cell reaction equation by writing the half cell equation at the anode, which we have chosen H2O molecules to be oxidized at the anode, and the cathode kita dah choose copper to be the one yang undergoes reduction at the cathode. To write the overall cell reaction equation, kita kena balance out the number of electron first at the anode and the cathode, which kita akan kalikan multiply by 2 for the half cell copper reaction at the cathode, so that kita boleh dapat balancekan the electrons, and the overall cell reaction that you will get is this. Okay, so observation ni adalah benda yang sangat penting because ni adalah bila you nak describe the electrolytic cell punya process, this is what you need to include lah, which is observation. So observation, you can say at the anode, since that kita choose H2O molecules to be oxidized at the anode, so the oxygen bubble gas will be released, the solution will become acidic since H plus ions are produced. Okay, and at the cathode we can see the copper solid will be deposited sebab kat sini dia menghasilkan copper solid as the product at the cathode. Okay. The next question, it asks you to state the change of the color intensity of the solution in the cell and explain your answer. I believe that the color of copper to sulfate solution will be less intense as at the cathode. Kita dah menghasilkan brown solid copper. Okay.